All right, guys, so this is going to be a very short part of the lecture module, and we're focused on section 3.1.4, which concerns information resources. Basically, where can you go to get information that you need as a laboratory worker? That's really all that we're going to do in this section. So I'm going to introduce you to some publications and some online resources that could maybe help you out while you're in the laboratory. But just like before in all of the other sections, we're going to start off with an incident. So it says, during the preparation of methyl azide from dimethyl sulfate and sodium azide, an explosion occurred. All right, so that's going to be the number one thing that we're going to be looking at. It's this explosion, right? So something's had to happen in order to create this incident in the laboratory, and we got to figure out maybe what happened. It says the same reaction had previously been carried out without incident at all. So something in this particular case went wrong, and we've got to figure out what it is, because all the other times nothing has happened. But now all of a sudden we get an explosion. Well, just like we've said before, and we've discussed this possibility before, just because it's happened the same way every single time without incident does not mean that a mistake cannot happen in the future. So, upon investigation, the chemist found that the Bretherick's Handbooks of Reactive Chemical Hazards reported that this reaction can result in an explosion if the acidity of the solution drops below a pH of 5. So we've got a reaction here, and this reaction is pH dependent. All the other times, probably, this pH has not been disturbed. But this says an explosion could happen if the acidity drops below pH of 5. So maybe, just maybe, in this particular case, at this particular time, something happened. The pH went below 5, and we get an explosion. It was surmised that the sodium hydroxide, which was added to maintain the pH above a 7, was not added at a sufficient rate to keep the solution at the required pH, right? So sodium hydroxide, this stuff is a base, and this makes the pH greater than 7, and that's what we want. If it drops below a 5, it becomes explosive. So basically what they thought is that this sodium hydroxide wasn't added quick enough, or it wasn't added in the proper amount, and because of that, the pH began to drop. Further steps, visible color indicator basically, were taken in subsequent preparations to ensure that the pH was maintained in the appropriate range. So here we finally see a modification of the method, right? So if we see a mistake that could happen in a laboratory, and this is a prime example of a mistake that's random that happens, this modification to the method can help save this explosion in the future, right? And it's actually surprising that this wasn't done beforehand anyway. It looks like if it is pH dependent, a indicator does nothing to the reaction. It's just something that's visual that we can see straight. It's like phenolphthalein indicator, if you've ever used that before. It's clear. You do not see a color at all in acidic solution. But once it goes basic, it turns pink. So this is something that they've used here in this laboratory method to kind of prevent these explosions and these incidents in the future. So we learn from our mistakes. That's what's happened. And just because it's written down in an SOP, just because it's been done over and over and over the same way every single time without incident, does not matter. It does not matter. Because at any point in time, something weird and wonky can happen to you in a laboratory, and you've got to be prepared for it, right? And that's hopefully what this class will allow you to think about and allow you to do. So if you noticed in the incident, they mentioned a reference book, and we're going to talk about that reference book in just a second. But that's kind of the purpose of this whole section. A very, again, brief section, but we're going to talk about resources. What is out there available to you? Now, we know that SDS or MSDSs are out there, and that is a resource, right? You can use that in a laboratory. You can use it to figure out what kind of safety information is out there on that particular chemical. But there's other things besides SDS and MSDS, right, folks? We've got the whole internet at our fingertips, and we have tons of different journals and research articles and reference books that we can call on for information. And you need to become aware of some of these very common books. Yes, I said books. That is available to you in the laboratory field. So we're going to be talking about printed, and we're going to be talking about internet resources here. Both of these can be used in a laboratory. All right, before I go any further, I use them, you use them. Normal people that work in a laboratory every single day use both versions of these types of reference sources. But you've got to keep something in mind, okay? You can't believe everything you read on the internet, people. Okay? So just because someone has written an article, just because someone has put something in a blog, just because someone made some type of picture and put it on Facebook for you to read, you do not believe every single thing that you read. If you are one of those people, I hate it for you. Right? You've got a lot of learning to do, as my mama and daddy would always say to me. So we've got to figure out what is fake from what is real. Okay? So, printed resources. Printed resources can be fake. And internet resources, oh gosh, don't even get me started. If I had to compare the two, internet resources are majority fake. Well, no, I won't go and say the actual majority word, but I'm going to say that you're going to have a very easier time finding an article or finding some type of entry on the internet that is fake, that has no justification, that's not been verified, much easier than you would printed. Now, printed sources, yes, they can be fake. And when I say fake, really what I'm kind of referring to here is maybe the word outdated. Depending on the year that it was published, things can change. Now, physical properties of a compound, it's probably not going to change, okay? But maybe some new discoveries about that particular type of compound has come to fruition, and we need to let other people know about it. So outdated publications can happen, and they are out there, and you can use them as a resource and not even know about it. So the question that I always get is, hey, can we use Google to find information that we need? Or can I use something like Wikipedia to try to find information that we need? The answer here is not very easy. I'm going to put a big fat no beside of them. Now, that doesn't mean that you can't use these for certain pieces of information, but if you're looking for something that's academic, if you're looking for something that's reliable, do not use Google and do not use Wikipedia. All right, there's other sources out there that are going to be much better for you to use as a laboratory worker that you can trust to make sure that no one's giving you faulty or fake information. Now, Google and Wikipedia can be used if you're just simply looking for physical properties. All right, so what would be physical properties? This would be something like boiling points or melting points, maybe density, formula weights of compounds. All of these things you're going to learn in a general wet laboratory course or a entry-level chemistry class. All of that information is verified. all of the information comes from typically another reference source, and that reference source gets added into the Wikipedia article or the Google link that you have found, and it's referenced, it's cross-verified, and they put a big check mark beside of it, especially if you're using Wikipedia, to let you know it has been verified, and you can kind of trust that information that's coming from the site. So most of the physical properties are going to be verified on Wikipedia if you decide to use that in the future. But you've got to keep in mind that these are what we would call open source, meaning that anyone from their bedroom at 3 or 4 in the morning, if they wanted to, could go onto these websites and post some kind of weird, wonky article for you to read, and if you're not careful, you might believe it. Or they could go into Wikipedia and they could add statements or add clauses or add weird, wonky information in there as well, and to the untrained eye, you would take that as a fact and you would report that fact, right? We don't want that to happen. Contributors come from everywhere. Contributors could be an 8-year-old boy in a science class halfway across the country and you would never know about it. So what I'm trying to tell you is that even if you use something like Wikipedia, you have to understand that it might not be 100% accurate. That's the problem. It's always been the problem. Very often you sometimes hear of professors that want to create some type of online textbook, kind of like Wikipedia would be. You would read a section and then words would be underlined. You would click on those words and that would cross-reference you to other sources, and they would basically sell this textbook as like the modern version of a textbook that's very similar to Wikipedia entries. The problem is that they rely on multiple people to go in and add information in at any point in time. There's very strong negatives associated with that type of textbook, because where's the information coming from? How do we know that it's going to be accurate like a published textbook would be, that people can't go in and change on a whim's notice? Now, Google. Let's talk about Google. Google, same type of thing here. Who knows what type of website you're going to stumble across? Don't take any of that information seriously, right? Now, granted, if you are on kind of a trusted website that's, known, and we'll talk about some of those, then yeah, you can trust those types of resources without a problem. But just a common web page that someone has created, or a website devoted to a certain topic that someone else is managing, those are the ones that you have to watch out for there. However, Google can be used, of course, to search for SDSs. That's great. That's what we can use Google or another search engine for. It doesn't have to be Google. And those SDSs or MSDSs we know are kind of trusted, but at the same time we also know now that MSDSs or SDSs do not have to be 100% accurate either. There's a disclaimer in them. So overall, this is what I'm going to tell you. The best resources, the best ones, are those that are printed and verified. There's plenty of reference text that are out there available to you. We have some in our laboratory. When you go work for a company, you will find some of these reference textbooks in that laboratory as well. We've got them in a library. You never been to the library? Now's your chance. You better step in at least one time in your life. Not everything can be found on the internet, people. But overall, the best resources that you have at your disposal are going to be printed ones that are verified. So in the next video, we're going to talk about these resources. We're going to talk about what's out there, what you can trust, I'll show you some websites that you can go to take advantage of, not only in this class, but in all the other classes that are upcoming in the program as well. So maybe jot these down into a lab notebook, maybe jot them down into front cover of a composition notebook, so that way you'll always have them at your disposal if you need to use them at any point in time. So in the next video, we'll pick up from here and we'll talk about what some of these resources are.